Okay, in this mixture problem, as you can see, I've written it down. It's the same as question 33 on page 111. Underneath it, I have these three rectangles. They represent the containers, and that's just my preference. I like that visual of seeing that I'm going to take two separate containers, combine them together into a final container with the mixture of the two. Now, I require 100 milliliters of 8%. So I will write that in my final product, 100 mils of 8% solution. And I'm going to get that by combining a 5% solution and a 15% solution. Now the question is, how much do I need of each really to get that 8% solution? And I don't know, but I do know that the two added together must be 100 milliliters because my final solution is 100 milliliters. So I don't need two variables, I just need one. I'm going to call X milliliters of the 5%. And since the two solutions combined need to make 100 mil, that would mean that the other solution is going to be 100 minus X milliliters, and that is a 15% solution. So I've translated this paragraph into these containers, and now I'm going to do it one step further and translate these into an equation. Of means to multiply, if you remember. So 0.05, we change 5% to a decimal, times X. Then I have 0.15 multiplied by the quantity, 100 minus X. And then I have 0.08 multiplied by 100. And that's it. Now we just need to solve the equation. So 0.05x plus, and I have to distribute 0.15 times 100 minus 0.15 times x equals 0.08 times 100 is just 8. So I have 0.05x, 15.15 times 100 is 15, minus 0.15x equals 8. I will combine these two together. That would give me a minus 0.10x equals, and if I subtract 15 from both sides, I get minus 7. So I divide both sides by 0.1, negative 0.1, and that would give me 70 as the final number. Now what does that 70 represent? It represents how milliliters of the 5% solution, because X represented the number of milliliters of the 5% solution, which means I need 30 mil of the 15%. We are finished.